Hi everybody. So in this video we're going to look at what's called a piecewise function. And a piecewise function is a function defined by multiple subfunctions each applying to a specific interval. So we can think of it as a function that follows different rules for different input values. And we have a piecewise function in example 1, where given the domain of x less than 0, we have a subfunction x squared minus 4. And within the domain of x greater than or equal to 0, we have a subfunction 8 minus x. So with these kinds of questions, it's a good idea to sketch both subfunctions for all values of x. So if we begin with x squared minus 4, well, this will be a quadratic with an intercept of negative 4. So it will look something like this, when this value is at negative 4. And for 8 minus x, well, we'll have a negative gradient and a positive intercept of 8. So that will look something like this. And it's a good idea when sketching these graphs to label as many key points as we can. So we can label these two roots as x equals negative 2 and positive 2. And we can label this solution as 8. So now we can think about the specific interval given. So here we've got x is less than or equal to 0. So what we're interested in is when x equals 0 and when x is less than 0. So we're thinking about this curve here, which means this bit isn't needed. And in the second subfunction, we're only thinking about a domain where x is greater than or equal to 0. So we're looking at this part. And with x squared minus 4, we're told that x cannot be equal to 0. So we've shown this with a hollow circle. And with 8 minus x, we're looking at x is greater than or equal to 0. So we're looking at a full circle when x is 0. So now to sketch f of x, we need to put these two subfunctions together. So we have our quadratic with an intercept of negative 4. And then our straight line has an intercept of positive 8, which is a full circle, and negative gradient. And I should also state that this is negative 2, and this value is positive 8. And we have a hollow circle at x equals 0. So this is the sketch of our piecewise function. And now to state the range, well, and we know it's a one-to-one function, because every element in the domain maps to a distinct element in the range. When x is 0, it doesn't map to negative 4 because it cannot be equal to, but it does map to positive 8 because it can be equal to. And I'll just write 8 here. So because it has a one-to-one mapping, it is a function. So therefore the range, well, this quadratic will shoot off up to infinity as x gets less than 0. And this straight line will shoot off to negative infinity as x gets bigger than 0. So what we say is the range f of x will include all real numbers. Okay? Let's try example 2. Okay, so in example 2, we've been given the function h of x is defined by the square root of x in the domain of 0 to 1, including 0 but not including 1, and 2 minus x in the domain of 1 to 4 inclusive. So do you want to try and sketch y equals h of x and state the range? And then for question B, if you can state the type of mapping for this function hx. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So if we begin by sketching the square root of x between 0 to 1, well, the square root of 0 is 0, and it can be equal to this, so it'll be a full circle, and the square root of 1 is 1, but it cannot be equal to that, so it'll be a hollow circle at 1, and we know it's a square root, so it'll be a curve. Then if we look at when x is between 1 and 4, we've got 2 minus 1, which is 1, and it can be equal to this. So now it'll be a full circle. And when x equals 4, we've got 2 minus 4, which gives us negative 2. So we've got 4 and negative 2 here, and it can be equal to this. So then we've got a straight line passing through the 2. Okay? So h of x has a range of it can be equal to 1 and it can be equal to negative 2. So it will be less than or equal to 1 but greater than or equal to negative 2. And for part B, with type of mapping, well, if we consider the values between 0 and 2, we can see that we have multiple elements in the domain that map to a single element in the range. So therefore, this is a many to one mapping. Okay? Well, thank you very much for watching, and I hope you found that useful. If you did find that useful, please like and subscribe, and you can download the full lesson and worksheet from my website, msmathematics.com. Another link in the description below. Thanks again, and take care.